All right, well, let's look at lesson 6-4. On the front side, we're looking at the graphs for numbers 1 and 2. So for the first one, remember this x plus 4, that plus 4 is inside the parent function. So that means we're going to do the opposite. We're going to move that graph to the left 4 units. Now remember, the original function has an asymptote here at x equals 4. So I'm going to move that over 4 units to the left. So this would be where my new asymptote would be. And this x-intercept, we're going to move that to the left 4 units. 1, 2, 3, 4. And if you wanted to find other points, you could, but otherwise, I just want to have the general idea. So get a nice curve in your graph there, and make sure that it doesn't cross over that asymptote. That's what I would be looking for. So make sure that you graph your asymptote, and at least one significant point there, usually the x-intercept. All right, so let's find the domain and range. So remember the domain, there is no values past or to the left of -4. So the domain starts with -4, and then it goes to the right infinitely. The range, it goes infinitely up and infinitely down. And the end behaviors, x approaches -4, so that would mean on the left side of the graph, it's going down towards -infinity. As x approaches infinity, the graph on the right side is continuing to go upwards, so it approach positive infinity. And unlike the previous examples that you did in the pink section, these are not horizontal asymptotes, these are vertical asymptotes. These are going to be in the form x equals, and it would be x equals -4 for this first one. All right, so this one, the vertical asymptote, or the asymptote, or the whole graph rather, is moving up 2 units. Now it's not moving left to right, so that means the vertical asymptote is not moving up left to right, it's only moving up and down, so in which case it's not going to change location. And if we take and move all those points up 2 units, like this y-intercept that was at 1, 0, move it up 2 units, it's going to be now at the point 1, 2. So that would be the shape of your graph. Now again, this one here starts at 0 and goes infinitely to the right. So it'll be your domain, because there's no, if we squish on the x-axis, there's not going to be any values to the left of 0. The range, if we squish that on the y-axis, it goes from -infinity to infinity. And as x approaches 0, so that would be the left side of the graph, it's going down towards -infinity. The right side of the graph is going up towards positive infinity. And the asymptote for this is a vertical line, so just like the previous one, it's going to be a vertical line at x equals. So that's how you'd sketch a graph of that one. All right, let's look at the back side. So the back side is still with lesson 6-4. And remember, here's where we have to find the inverse. Remember, the inverse, the first step is to change the x to a y and the y to an x. You might be saying, where's the y? Remember, f of x, that's just function notation that replaces y. So now we're going to do that first step of changing the x to a y and the y to an x. So we have x equals 3 to the y power minus 5. So my goal now is to solve for y. So if I solve for y, I want to get rid of everything on the right side. So I'm going to add 5 to both sides. So we get x plus 5 equals 3 to the y power. And then at this point, what we'd want to do is we'd want to change the form it's in. And if I change the form it's in, we would say that this is a log with the base 3. And our value would be the x plus 5 equals your exponent, which is y. So I want to make sure that you remember where to put all those different pieces. Look back in your notes where we talked about that. So this is what we put in the box, or in the blank here. All right, let's look at the next one. So the next one, same idea. We want to start. That g of x, remember, is the same as y. So we're going to start by changing the x to a y and the y to an x. Now on the right side, that minus 8 is part of the exponent. So we don't add 8 to both sides because that would be wrong. So I'm stuck right now. So the only way to fix this would be to change the form it's in. So I'm going to change it to logarithm form. So our base would be the 2. Our value is what it's equal to, the x. Remember, all logarithms equal your exponent, which is y minus 8. So now to solve for x, we would add 8 to both sides. So that would be your answer. All right, let's look at number 5. So now this one's already in logarithm form, and we need to find the inverse. Same process. So that h of x is still the same as y. So I'm going to change the x to a y, y to an x. That's my first step. Always your first step. And now we're going to change the form it's in. Now we want to make sure the log is by itself, so if there was something like +7 or -8 out here, we get rid of that first. There's nothing there, so now we can change the form it's in. So remember the trick that I showed you if you're in my class. Remember that base is the base for our exponential equation, and logarithms equal exponents. So all we have to do is just drag your base over, so we would have 3 to the x power equals, when we drag the base over, it's no longer in log form anymore, so we just have y plus 11. So now to solve for y, I would just subtract 11 from both sides. So that would be my answer, 3 to the x power minus 11. All right, so that's the end of the yellow section, which is lesson 6-4.